Alrighty, here comes problem number 5 from the Chapter 1 review. So for this problem, we are in New York City. The heights of the observatories of One World Trade Center, the Empire State Building, and the Rockefeller Center are, and then they give us 3 numbers, and they say respectively. So that means they're given to us in order. So One World Trade Center, and this is really sad. That's the building that came down on 9/11. So be nice if they updated this textbook. So that is 382.2 meters. The Empire State Building is 320 meters, and Rockefeller Center is 259 meters. And then the horizontal direct distance, so not taking the streets, but just like as the crow flies, is 4,600 meters from the World Trade Center to the Empire State Building. And then from Rockefeller Center to the Empire State Building, it's 1,310 meters. Okay, so we are asked to find the angle of elevation from the observation decks of the Rockefeller Center to the Empire State. All right, so the observation decks are at the top of the buildings so that you can look out over the city. And from Rockefeller Center, we want to know if you were standing on the top of Rockefeller Center, what is the angle that you would have to look up at? What is the angle you have to look up at? So in order to get an angle of elevation, you need to first draw in a line parallel to the ground. Oh, look, my cello music is on the opposite side of this. That makes it kind of handy for, for having some lines on here. So let's see. So we're just going to draw that straight across. So this is the angle of elevation. So if I was standing here on the top of Rockefeller Center, how far up would I have to look? What number of degrees would I have to turn my head up in order to be looking directly at the observation deck on top of the Empire State Building? Okay, so we have a right triangle here. So I'm going to take that little right triangle and I'm going to figure out this angle. So I already know the horizontal distance here. It's 1310. And I can find the vertical distance here because it's just the difference between the height of the Empire State Building and Rockefeller Center. Because 259 is this, so this is 259. So I just need to do 320 minus 259, and that'll leave me with this. Okay, so I can take this cute little triangle. I'm trying to find this angle here. I know this is 1310. And this I'm going to do 320 minus 259 to get that. And it's a right triangle. So once I get that number, I can use my SOHCAHTOA. So this is opposite over adjacent. So this is going to be tangent. So the tangent, I'll go ahead and call that theta. The tangent of theta is equal to the opposite over the adjacent. TOA. Okay, so I'm going to have 1310 on the bottom. And let's go ahead and subtract that 320 minus, what did I say, 259. And that gives me 61. So it's going to be tangent of theta is equal to 61 over 1310. I'm then going to use, to get theta by itself, I'm going to use inverse tan of 61 over 1310. So on my calculator, which you probably can't see very good as usual, let's tilt it. Okay, so second tangent, and it was 61 divided by 1310. Enter, and I get 2.666. So if you look in the back of the book, I believe it said the answer was 2.7. Why they're not rounding off to 3 significant figures, I don't know. Kind of bugs me how this book is doing that. So theta is approximately equal to 2.67 if we're going to 3 significant figures. And I was working in degrees. You can see up here I'm in degrees. This they didn't specify how they wanted the answer, so it's our choice. So I'm in degrees. All right. Okay, now I need to do it again. So now I'm going to come over here, and I'm going to go from the Empire State Building over to the World Trade Center. But this time, they're talking about angle of depression. So it says, what is the angle of depression from the World Trade Center to the Empire State Building? And I suppose you could argue that there is no angle of depression because the World Trade Center no longer exists, but we're just going to go ahead and do the math anyway because this textbook clearly needs to be updated. All right, so angle of depression. Okay, you might think it's this angle right here. It is not. It is, if you were looking straight out, how far down would you have to look? So this is the angle of depression. Now, notice this line is parallel to this line. So therefore, alternate interior angles are congruent. So I'm actually looking for this. So the angle of depression from the World Trade Center is the same as the angle of elevation from the Empire State Building. This angle right here is congruent to this angle over here. Okay, so you kind of needed to know that about angle of depression. And if you had looked back in the textbook, I don't think it gave it right there in the chapter summary. You would have had to go searching for it. But that is what angle of depression is. Okay, so I'm going to make my cute little triangle again, just like I did for this one. I'm going to do this one. So I have my cute little triangle. I know it's a right triangle. I know the base is 4,600. And again, I can find this distance here by subtracting the heights of the buildings. So 382.2 minus 320 is going to give me that height. And I'm going to call this angle, I'll call it alpha. All right, so same thing. It's still going to be tangent. So tangent of alpha is equal to, let's go ahead and subtract those. So 382.2 minus 320 gives me 62.2 divided by 4,600. We're going to do inverse tan of 62.2 over 4,600. So I've got my second function tangent to get my inverse tan. And that was 62.2. I can select it. It's already in there. Divided by 4,600. And I get my answer of 0.775 if I'm rounding off to 3 sig figs. So approximately equal to 0.775 degrees. Not much of an angle of depression there. Okay, so in the textbook, they rounded it off, I believe, to 0.77. I don't know why. But that is it. Okay, so here's the angle of depression off of the World Trade Center and the angle of elevation off of Rockefeller Center. Very slight angles. And that's that. And stop.